Okay, a baseball is hit along the third base line with a speed of 100 feet per second. At what rate is the ball's distance from first base changing when it crosses the third base? So, a couple things that we need to know. If you don't know anything about baseball, this is third base. So, this is first base. The other thing we have to know is that this makes a perfect square. So if this length is 90, this length is also going to be 90. We want to solve for the rate this distance right here is changing. So if we look at what we have a right triangle. So I'm going to go ahead and just copy this triangle here and then move it. So the other thing that we want to know is it says when it crosses third base. So this picture is a little misleading because we want to know when it crosses third base, meaning when it's right here. So this is the triangle we want. We know this side is 90 feet, which means this side is going to be 90 feet. And this side, although we don't know, is the rate of change that we are looking for. ds over dt is this side because this side is s. So ds over dt is how fast the ball is traveling. The other thing that we know is that first base isn't going to be moving, so the ball's distance from first base is going to always be consistent, or this side of our triangle is always going to be a consistent length, meaning that the rate of change of this side, which I am now going to call y at this point, is equal to 0. So we have a right triangle, so we need to use Pythagorean theorem. So we have a squared plus b squared equals c squared. I'm going to change it so it matches up the variables we have. Our two sides are s and y, and it's equal to x squared. If we were to take the derivative, we have 2s ds over dt plus 2y dy over dt equals 2x dx over dt. Everything has a 2 in common, so I'm going to go ahead and divide by 2 to just have the side times the rate of change. Okay, we're going to plug in what we know so far. So s is 90, ds over dt is 100, y is also 90, dy over dt we know is 0, we don't know what x is, and we are solving for dx over dt. So we don't have one of the things that we need, which means we need to solve for it. Thankfully, we have the Pythagorean theorem to help us solve for that side. So we are going to now use the Pythagorean theorem to solve for what x would be. So s squared plus y squared is equal to x squared. So we have 90 squared plus 90 squared equals x squared. 9 times 9 is 81, and we are going to have 8100. If I combine these two together, we should get 16,200, which means we are going to have the square root of 16,200. This is not a very nice number, but if we have a calculator, it really won't be that big of a deal. We could plug that in, no problem. But if we think back to what we have a right triangle where two of the sides are the exact same. So this would be a 45, 45, 90 triangle. which is not what I have here, but it is. It is now. So if we have a 45, 45, 90 triangle, this side is going to equal this side. Our third side is equal to whatever our side length is times the square root of 2. This comes from taking the length of a square, the two sides of a square, and kind of cutting it in half. We would have kind of this idea of x squared plus x squared is 2x squared, and taking the square root of that, square root of 2 times x. In our case, our side value x is equal to 90. So x times the square root of 2 is going to be 90 times the square root of 2. Between these two values, one of them is easier to work with than the other in this particular problem. So I'm going to use the second one, 90 times the square root of 2, because if I look at my problem, everything has a 90. So I can rewrite this. We have 90 times 100. I could multiply those out. We have 90 times 0. Going to get rid of it. Equals 90 square root of 2 times dx over dt. Well, I have a 90 on both sides, so I'm going to divide everything by 90 to get 100 is equal to the square root of 2, dx over dt. I can now divide by the square root of 2 to get dx over dt. So 100 divided by the square root of 2 is the rate of change of the distance between first and second base, or the ball's distance to first base when it's crossing third base. So the rate, the distance of the ball to first base is increasing by a rate of 100 over the square root of 2. It's in feet, and it's per second when the ball is crossing third base. This problem, once you kind of know what to do with it, is not too bad. It's just kind of understanding that we're dealing with a right triangle still in order to kind of do everything else.